Well, let me thank you for inviting me. I'm very, very flattered and very honored, and I'm really very grateful to be here. I'm a little gênée, as they say in French. I feel that I'm a little out of place because really Phil Wolfe should be in my place. I mean, he's the one who wrote the paper that you've all been working with. I was incidental in the sense that I think I probably produced the essential step from the quadratic to the linear. I mean, that was essentially, I've been trying to pick my memory from, it's 60 years ago practically. And I remember two essential things. I mean, I remember that I arrived from Chicago with my husband, and I knew absolutely nothing about optimization. You asked me about optimization. I mean, the word probably that didn't exist for me. I was working on Lie algebras. I discovered new simple Lie algebras of characteristic P, not 2, by the way, P greater than 2. I was starting from scratch because I was made to belong to that prestigious group which you know about in Princeton, run by Kuhn and by Tucker, Al Tucker and Kuhn. And, all the prestigious, the beautiful mind people had been in there before me several years. And I knew nothing about any of this stuff. And I started to find out about linear programming, the simplex method, Danzig, game theory, all in one fell swoop in a way, because I felt I had to work with the team. And I was really assigned to Phil, who is an optimizer. I mean, he's really somebody who's been trained in this. I think he published in it already, probably. I can't remember. And so I can't really remember too well, but I seem to remember, I must have taken courses in Lagrange multipliers and all kinds of things that I really didn't know about. And the Kuhn-Tucker, which is now Carouge-Kuhn-Tucker, right, multipliers. So all this was new. And at a certain point, I suppose the quadratic problem must have been assigned as a way of progressing from linear programming to concave programming. And I seem to remember Phil and I talking about it. He had an office, he was postdoc. I was pre-doc. I'd come from Chicago, from Harvard, Albert thesis, written my Lie algebra thesis in Chicago, and was on the point of getting my degree. But I was on the lower level, obviously. I wasn't, he was definitely in the math department. I was a visitor in that group for 1 year. And so I was working at home, and I seem to remember working at home with scraps of paper, and then one day coming to see him, which we'd meet regularly or irregularly, I don't know, and saying, I think this should work. And I seem to remember, and there I hope, I'm not imagining something, I'm not in my own movie, that Phil said Kuhn came by, Harold came by, and I seem to remember Phil saying, I think Marguerite has solved the quadratic problem, and, feeling pretty good about it. Now, is this my imagination a little bit or not? I don't know. But I know he was looking at my notes, and the one thing I think I told you that made me feel very cheerful, now in retrospect, is that he looked at me reproachfully after having looked at it and said, but you didn't prove that your iterative method converges. So, as I said, paradoxically, this kind of reproach now, a century later, makes me feel better, because it makes me feel that, obviously I must have come through with something that hadn't been complete, but which somehow he knew he would work. And he promptly then showed that it converged. And then proceeded to write the paper, because you can see the thing is written by somebody who's a professional. I mean, it's written, on a very high level, and it's so I certainly didn't have anything to do with that, because I didn't have the background. So my contribution, maybe, that little spark at the beginning, but that's it. And I was an algebraist, and I think I was trying to think of things to say, apart from the fact that Phil really deserves, a huge amount, if not most of the credit, certainly for the article. But that it's good to work with people from different fields. I mean, that it's nice to mix. It's nice to have a general culture in mathematics and know about other fields. I think in general it's very enriching. So from that point of view, we were productive together. Everybody was very pleased, and that's it. So if you ask me anything about optimization, I think I don't know. I mean, trying to optimize my own life, I think it was my main...
I have a question on Lie groups.
Okay.
No, I'm just kidding.
You have a question?
Oh, no, I said on Lie groups.
Excuse me?
On Lie groups of...
Well, I won't tell you anything about Lie groups because I worked on Lie algebras, but I know they're essentially the same. Anyway, I forgot all about that. But it's the same thing. They're non-associative. It's non-commutative, and they do all kinds of weird things. But when I found a new one, obviously, there hadn't been a new one for a long time, a new simple one. I mean, they're all composite of simple one, and one or two were known, but not for a long time. So I worked with somebody called Adrian Albert in Chicago, who's an algebraist, and who was he didn't know me from Adam when I walked in, and said, why don't you look at my papers, and came up with a topic. And this for me was a real, there couldn't have been a nicer way to handle me. I mean, I had been at Harvard, I had been a kind of, I'm saying this for all of you, I don't know what level you are, but I was a kind of thesis dropout because I had done extremely well. I was 20-something, very young. And I had worked with Richard Brouwer in Toronto, who was at Göttingen. He's a top algebraist. And he had said, you must work with Oscar Zwicky. This is the way he'd just been hired by Harvard. And he's obviously one of the people one should work with. And that was catastrophic for me. I mean, I just had, it was algebraic geometry. I have no geometric imagination. And the story of my life, I'm, bearing my soul psychoanalytically in this mathematical context. So I was it just didn't work out that year. I tried to read Severi, who was a great Italian geometer. I don't know if you even heard the name, but he was one of the most prestigious names, of a great authority. And I was supposed to find a thesis topic, and it didn't work out. So I followed my husband to Chicago, thinking I would then find another thesis advisor, and this was Albert. This was very fortunate because that's really when I feel comfortable in algebra, when I'm fiddling with all these symbols and trying to organize things and find some kind of scheme. I mean, that's essentially how my mind works on any level. Whether I read, I'm a great novel reader, and at the moment I'm working on. I'm thinking of some kind of schemes that are shared by a lot of novels, which are tied up with paradox, which has always fascinated me. And okay, so now I'm beyond my topic, and anybody wants to ask me? Yes.
So how did you move from the algebras and positive characteristic to optimization? Did it just you happened to get assigned to that group?
How did I move from there?
It seems like a...
Well, this is the whole point. That's why I'm going through this kind of soul bearing, because I arrived in Princeton just as a bright woman who was on the point of getting her doctorate and very highly recommended by Albert. To Albert, and Tucker took me on in that group as a result, because my husband was in Princeton giving a Gauss seminar, so there I was with a young mathematician. Could they use me? And they very generously put me in that group and paired me off with Phil and made me learn all this about optimization. After that, I really didn't give up optimization because I went back to Lie algebras, but I also went then after. It did help me professionally in the sense that since I was a wife and a mother, And the question of is very problematic for women, as we all know, or as we should discuss, because of full-time work and stuff. Actually, the optimization helped me get jobs because it was easier to be employed in business school or engineering schools with the claim that I knew something about optimizing. So, which is what happened, really. Later on, I worked in transportation. I have a few articles in transportation science, which are all based on equilibrium between, origin and destination, so that all the costs are the same on all the paths. I mean, that's optimization too. Much easier, certainly, than quadratic programming. But with a paradox there too, which you said was called in German a nasal something, a donkey pass or something. Taking a path from the origin to the destination, which is more expensive, than the equilibrium.
So I have a question for you, but from what you just said. So you worked in, I guess, I didn't know you worked in transportation.
Yes.
And on wardrobe equilibrium and the user equilibrium concept?
Yes.
So are you aware that one of the main methods for solving those problems is something called the Frank-Wolfe method?
No, I didn't know that.
So,
I had no idea that I was meeting myself again and how to circuit, as I can say that word, route, yes.
And I would say nor did I, because I started working on Frank-Wolfe a year or two ago, and then I ran into a colleague who was working in transportation, and when I mentioned this to him, he said, well, that's what we use to solve wardrobe equilibrium problems now.
That's really amazing, because when I was doing wardrobe and the Brace paradox, I don't think I was using myself at all. I mean, for one thing, the costs were linear, and yes, well, that's very interesting. Thank you.
You're very welcome. Thank you.
Anybody else?
Yes.
So what's wrong with characteristic?
Excuse me?
So what's wrong with characteristic 2? You said you studied the algebras in characteristic greater than 2. I'm just wondering what structure breaks down.
I think I was saying this, and I think I was probably wrong, because I think it's probably any P would do. It's just a 2 would be ridiculous, but
Is it because you lose anti-commutativity?
and any P, any prime fields.
There are a lot of algebraic results that break down characteristics.
Yes.
I see.
So I was wondering, what was the situation as a woman in science at the time? Like, were you the only one, or
Where?
in research?
Well, in what place? At Harvard?
Choose.
Well, in most places, yeah. At Harvard, there was another woman who also was European, Liesel, somebody who's 2 years ahead. But this was a year when a lot of GIs came back, actually. So there were big classes and mostly masculine, and this one woman. And then at Princeton, which was a much smaller group, and there weren't any women, actually. No, I don't remember. No, much smaller group, actually. Michel Belinsky. You see, I didn't even know. One of the questions you asked me was, did I know about Frank-Wolfe being? No, I didn't. I had no idea that it was being used as much as it was, and I had no idea about this meeting. And I only heard about it completely by chance because of Michel Belinsky, who just got, as you know, the von Neumann Prize, and who's an old friend. He was younger than us. And he taught at Princeton for a few years, and he went elsewhere. And I was a very good friend of his wife, who just died, who was just wonderful, his first wife. And so Michel just sent me an email saying, with this kind of completely hermetic statement about greedy algorithms. And I had no idea what this meant. And when I came back, I just manifested myself, I thought, indirectly through the Katz-Nelson, because I thought, since nobody knew I was at Stanford, I had to make some connection. I didn't want to call you directly, so I just went through this devious social, mathematical network. And I'm very, very honored, very pleased. And as I say, I do have a feeling of malaise about Phil not being by my side to really be in the spotlight, because he's really it's really his field. But I may, obviously I was essential at the beginning to make the whole thing take off, and for the article to come to your attention.
I have a question. So, could you share memories about how computing was done at that time?
Well, that's again, computing. I can hardly compute now. I mean, I just use it as a word processor. Was at that point clearly all the young men around, and Phil in particular, were obviously very, very familiar with computers and using them very basic. He was there with his computer all the time, as I remember, and. So I'm really, again, actually totally inadequate to discuss this. But I realized just from reading about VD, I just started to read about this a little bit and realized that you all have taken off from, my very slow, systematic, step-by-step method, and I'm just now throwing a lot of numbers around.
Yes.
This for me is a complete mystery. I mean, I don't understand to what extent. You'll have to tell me what this, is this throwing around of numbers completely, is it structured in a very definite way, or is it something that is completely, I don't know, I don't understand any of it. So I tried to read what you sent me, but it's Greek to me.
Swiss German.
So I'm sorry about being no good for the computer. So you'll have to tell me. I mean, I'm the one. I asked you. I read something about the fact that some people who who discuss computing in these articles I looked at claim that proofs are now maybe obsolete, and that maybe they can be dispensed with, and that some form of computing may take, a fancy computing may take the role of the formal proofs. Is this something?
What did you send her? I asked him what did he send?
No.
No, it's something I read, and I think I asked you about it. Yeah, I don't know what you said.
No, and these proofs become only more important to know.
But clearly, there's some question about this. There's some doubt. I mean, proofs may be on the way out. Is that it? I mean,
No, it's important to say.
I mean, I would say that these days in particular, in convex optimization, the two go hand in hand, in the sense that when people develop new methods, I would say there's two questions that are asked. One is, can it be proven to be a good method? Okay, so like the Frank-Wolfe method, the rate of convergence is known and it's established and everything.
You just use the steps.
And then the other question is, well, will it work up to that level in practice, or will it work much better, or in a sense, much worse than it's I would say, or only as good as its worst, as the worst case. Okay, so and that I would imagine most of the people in this room are writing papers with lots of proofs in them about algorithms, and so. But also, especially these days with big data and all that kind of stuff, the other question that goes hand in hand is also, so can it be practical? Can it be implemented in a practical way? Is that sort of a safe thing to say, or appropriate? Yeah.
And how is that tested? I mean, how does one decide one way or the other? Empirically,
I mean, it's people write papers that have computational results in them, and then that is evaluated the way you might evaluate any scheme. Were the problems chosen sufficiently?
Well, it's completely heuristic. I mean,
yeah, or is it just pure luck or something that happened, or Or if you see the performance is so much better than what you can prove, then you try and maybe prove something stronger.
Okay. So
Other questions?
then let's thank Marguerite again.